In example 5, we are supposed to plot these graphs in the same set of axes within these limits and range of x. And of course, in part B, use your graph to write down the solutions to the simultaneous equations. Now, we need to know how to plot these. And you can see the range. So plotting this for this particular equation, we have x and y. And of course, it goes without saying, when x is minus 2 is a straight line, so we don't need so many values of x. We can talk about when x is equals to minus 2, sometimes when x is equals to 0, sometimes when x is equals to 2, sometimes when x is equals to, let's say, like 4 even. When x is minus 2, then minus 4 plus y is equals to 3, and therefore y is equals to 3 plus 4, which is a 7. When x is 0, of course y is a 3. When x is 2, 4 plus y, 3 minus 4, which is a negative 1. And when x is a 4, this is 8 plus y is equals to a 3, and y becomes a 3 minus 8, which is minus 5. That is that for that particular. But for this one, we need to plot each and every value of y for the corresponding value of x, because it's quadratic, and it's going to be a U-shape because a is greater than 0. So let's talk about x and y also. We have to be careful here. Minus 2, minus 1, 0, 1, 2, 3, and even 4. And give the corresponding values of y. When x is minus 2, minus 2 squared is 4. 4 minus 6, that is 4 plus 6 is 10. 10 plus 1, 11. When x is minus 1, we have a 1. 1 plus 3, which is 4. 4 plus 1, which is a 5. When x is 0, you can see y is 1. When x is 1, we have 1 minus 3, which is minus 2. Minus 2 plus 1, negative 1. When x is a 2, we're going to have a 4. 4 minus 6, that is minus 2. Minus 2 plus 1 is a minus 1. When x is a 3, 9, you can see 9 minus 9, 0. 0 plus 1 is a 1. When x is a 4, 16 minus 12, that is 4. 4 plus 1, which is a 5. So we need a very accurate graph here. And we should do this on graph papers. But since we don't have graph papers, let us just try to be a bit accurate. We don't need so much of the negative value of y, the negative values of y, because the least we need is negative 1, but we are going to talk about negative 5 here. So we can assume that also minus 1, minus 2, minus 1. So 1, 2, 3, and 4. Having said that, it is important to note that we are going to have 1, 2, 3, 4, 5, 6, 7, 8. You can even have 9, 8, 7, 6, 5, 4, 3, 2, and 1. For the linear part, when x is a minus 2, we have a positive 7, minus 2, positive 7, somewhere there. When x is a 0, we have a 3. When x is a 2, we may be having a minus 1, minus 2, moving forward, minus 3. When x is a 2, we have a minus 1, and we can already have a very good straight line, and we can give it a name, which is already 2x plus y is equals to a 3. Let's come to the quadratic part. When x is negative 2, y is positive 11. When x is a negative 1, y is a 5. Y is a positive 5. So somewhere there, we are having something to do with that. When x is a 0, we have a 1. When x is a 1, we have a negative 1. When x is a 2, we have a negative 1. When x is a 3, we have a 1. When x is a 4, we have a 5. When x is negative 2, we said we are supposed to have a big number like 10, 11, minus 2, 11, somewhere there. And therefore, we are going to have another good, smooth curve, and you can give it a name. You can give it a name and have it like y is equals to x squared minus 3x plus 1. Having done that, we can now get to answer part B of the question, whereby use your graphs to write down the solutions to the simultaneous equations, the equations which are shown here. Of course, we are talking about the point of intersection. And if you are keen, you'll see the two lines intersect there, and you'll see the two lines intersect there. At this particular point, the value of x is equals to negative 1, and when x is equals to negative 1, y is equals to 5 at this particular point. For this particular point. For this one, this is another point of intersection. X is equals to, you can see, a 2, and y is equals to negative 1. So you need to be very careful when you're pairing up these solutions, because when x is negative 1, y is 5. When x is a positive 2, y is simply a negative 1. And that is it for that particular equation. Please note that when you're dealing with two simultaneous equations, one linear, one nonlinear, you are likely to get two solutions just because of the square part. All right.